Well, let us look at the basic working principle of the robot. This robot is a gesture controlled one where the movements and actions of this robot is controlled wirelessly. Basic working can be briefed in terms of this block diagram. It consists of controlling unit, processing unit and operating unit. Controlling unit refers to unit consisting of sensors like accelerometer, flex sensors at transmitting section. Processing unit at the transmitting section consists of a microcontroller that accepts these controlling signals and processes it for the transmission. The receiving end again consists of a separate microcontroller for processing the received signal. Operating unit comprises of DC motors and servo motors fitted to the robot that works according to the gesture of hand. Now let us look at the system level block diagram at transmitting and receiving ends. The transmitting side uses an accelerometer and two flex sensors to measure the gesture of hand. Thus, the obtained signals, referred as controlling signals, are fed to the inputs of microcontroller. The parallel output from the controller is encoded and transmitted through an antenna. At the receiving end, the antenna of the receiver picks up this signal and sends it to a decoder. The decoded data is then fed to another microcontroller that can drive two servo motors and a pair of DC motors.
This is the auto-control pick-and-place robot we have made. This is the globe on which we have mounted two flex sensors, an accelerometer ADXL 335, MSP 430 microcontroller, ST12E encoder, and a 433 MHz RF transmitter. A 7805 regulator IC given by Texas Instruments is used to maintain 5-volt supply to this entire transmitting section. This glove is used to control the actions of the picking and placing. This is the pick and place robot which have a detachable robotic arm placed on the base of the robot. This is the circuitry that receives, decodes, processes and supplies the control signals transmitted by the sending end to the motors of the robot. Here we have used a 433 MHz RF receiver, HT12D decoder, MSP 430 microcontroller, LM293D bridge. The base of the robot is supported by wheels fitted to 200 rpm gear DC motors and a caster wheel to gain sufficient speed. The robotic arm has a static base, a joint fitted with a servo motor that can make it move up and down, and a gripper fitted with another servo motor that can hold or release the objects to be picked or placed. The accelerometer at the transmitting end is used to control the DC motors. Thus, by tilting accelerometer, we can make the robot move forward, backward, left, right, or even pause. The flex sensor on the thumb is used to bend the arm up and down. Folding and releasing thumb makes robotic arm to bend down and up respectively at the joints. The opening and closing of gripper is controlled by the flex sensor on the forefinger. By folding and releasing the finger, gripper closes and opens respectively. Though the proposed idea is to serve patients, with the incorporation of extra peripherals and enhancement of robots' physical and mechanical features, it can find wide range of applications in defense sector, industries, home assistance services, construction sites, etc. Forward.
Left, right,
Back.
we thank Texas Instruments for giving us this great opportunity.